So today we're doing lesson 58. We did factoring with the GCF last lesson, and today we're going to do another type, factoring using difference of perfect squares, otherwise known as DOPS. We know some of this vocabulary. Difference means we're subtracting. Okay, you have to have a minus sign. And a perfect square is a number that you can take the square root of. So we're going to go back and review that a little bit. Before we get started on that, though, let's look at exercise 1. And you'll notice I already have my key up here. I think it's just a little bit neater, like I've said in the past, to look at my paper version of notes than to try to write quite so much. So exercise 1 says, consider in math, that's like, hey, look at this problem. Consider the expression 25x squared minus 4. So part A says, what's the GCF? Well, the only number that can divide into 25 and 4 is a 1. So 1 is the only common factor. And that doesn't really help us break it apart. It's just the same thing. So if you have a GCF that's a 1, a lot of times in class we'll say, well, there's no GCF, which really means there's nothing that we can do with it. We can still factor. So this is where our next type comes in. So this can be factored using difference of perfect squares, otherwise known as DOPS. And here are the steps. Pause the video, write the steps down, and then we'll go through this. Oh, actually, these aren't the steps. How can you tell? So we know there's no GCF that we can use. So now you're going to look and say, can I do difference of perfect squares? You can do that if there's two terms. It's a binomial. Has to be. If there's one term or three terms or anything other than two, you can't use this method. There has to be a minus sign. If there's a plus in between these two terms, you can't do it. And you can square root everything. If you can't square root everything, then you can't use this. So now we'll go to the steps. So first thing we had to do is check and see if there's a GCF. Okay, if there is, you got to do that one. If not, you're going to write two sets of parentheses, and you're going to put a plus and a minus in each set. It doesn't matter. You could also do this. Minus. They have to be different, okay? Either way is fine. And then we're going to fill in the blanks. So when you're factoring, here's a blank, here's a blank, okay? So there's 4 blank spaces. So what we're going to do is square root everything. The hardest part of this is knowing your perfect squares. So in the interest of knowledge and review, let's see if I can maybe zoom. There we go. Zoom this in. These are the first 12 perfect squares. Remember, a perfect square is something you can take the square root of and get a whole number. A lot of people think that 8 is a perfect square. You're not dividing by 2, you're taking the square root. And if you put that in your calculator, you're going to get a big, long decimal. So everything that I have inside a square root, these are perfect squares. These are things you can take the square root of. Okay? Notice 50 is not on here, 20 is not on here, 10 is not on here. These are your perfect squares. Make sure you copy these numbers down. You don't have to memorize them, but the better you know these, the quicker and easier these problems will be. After you've copied this down, then move on to the next page. Now, this is something totally different. You may have done square roots in junior high, but this is square rooting with a variable. So for this, it says to square root a variable, you cut the exponent in half. Okay, not the big numbers, the exponents. So I've done a couple of examples here. Oh, I lost my pen. There it is. So the square root of x squared. The exponent's a 2, so 2 divided by 1. Oops, sorry. Cut it in half. 2 divided by 2. You get x to the 1. Square root of x to the 10 is x to the 5. Doesn't matter how many letters you have. Over here, square root of x to the 10, y to the 6. Cut both of those exponents in half. And then the last example I did here, we have square root of 9, so I got a 3. Cut this exponent in half, x to the 3rd. Cut that exponent in half, y to the 7th. Okay, now let's see. So what we're going to do for number 4 is go through the first few step by step, and then you'll work on the rest, and I'll show you my answers. One tricky thing that happens a lot in algebra is whoever they are that makes up all these crazy final exams we have to do, they like to make it sound very fancy. So look at the directions here. Write each of the following as equivalent products, that's supposed to be 2 words, of conjugate pairs. Remember, product means multiply. So we are factoring. When you see something that says products, unless it's a word problem, it means factor. Now, a conjugate pair, vocabulary-wise, means you're multiplying 2 things that are exact matchers, except in the middle, they have opposite signs. Okay? You don't necessarily have to remember what that means, but if you know there's a reason behind it and it's, forgettable, then that's all you have to worry about. So I'm going to zoom this in a bit, and we are going to get started. Now, for the sake of time, I would tell you that none of these have a GCF. They all have 2 terms. They all have a minus sign, and they are all perfect squares, which means I can square root everything. So I'm just going to get right to our procedure. So I always like to start with my 2 sets of parentheses. And remember, the plus and minus can go in either set. That doesn't matter. So let's do the square root of x squared first. Remember, when you square root a letter, you cut the exponent in half. So it becomes x to the 1. You put that, since x squared is the first part of our problem, the answer goes in the first part of the parentheses. Now, we already went through the minus. It has to be there for the problem. Okay, you can't get around that. You don't need to worry about that. Once you realize it's there, all you are going to do is square root the 81. And the square root of 81 is 9. So that goes here. And we factored. We're done. Did it. Let's go to the next one. We have 9x squared minus 4. So we're going to do our 2 sets of parentheses, plus, minus, and let's square root that first term, square root of 9x squared. So we know the square root of 9 is 3, square root of x squared is x to the 1. That goes in the first space at the beginning and the first space at our second parentheses. Then we have the square root of 4. Square root of 4 is 2. There it goes there. Let's do C, and then you're going to do the bottom row on your own. Okay. Oops. Hey, I lost my pen, I think. Nope. 2 sets of parentheses with a plus and a minus. So the 25 is first, so we're going to do that one first. Square root of 25 is 5. It goes in the first part of the parentheses. And the square root of y squared, cut that exponent in half, is y to the 1. Now take note. Look, most people would want to say y minus 5 and y plus 5. You can't. The 5 is first. So now give the rest of these a try. Pause the video, and then I'll come back and show you my answers. Okay, so what I did here was I just wrote a little bit extra. I wrote what the square roots are. You don't have to do that. That's just, FYI. So there's my answers, 2x minus 9y and 2x plus 9y. Remember, you could put a plus sign here and a minus sign here. That part doesn't matter. What matters is the 2x is at the beginning of the parentheses and the 9y is at the end of the parentheses. So for letter E, 1 gives a lot of people grief. You can take the square root of 1. It's a perfect square because 1 times 1 is 1. And then this last one, what do we got hiding out over here? Okay, it doesn't matter which order you put the plus and minus signs. So I took my square root of 1 first, put that there. And then the square root of 4x squared is 2x to the 1. So guys, make sure you practice this. Your homework is pages 6 and 7. Give it a try and let us know if you have any questions.